All right. And calculus, as my good friend Carawalla has told me, calculus measures change over time, right? And again, in machine learning, they use derivatives and gradients to determine how a model should change itself to reduce the number of errors that could come about. And I provided a graph, right? Um, I think Carawalla is doing the physics section, or the physics part, which is the calculus part. So yeah, I took some inspiration from him. And we have gradient descent. I'll give you a scenario, right? Imagine you're like rolling a ball down a snow hill. The ball always moves towards the lowest point, right? And gradient descent, what it does is it updates the model step by step until the prediction has less error as much as possible. Yeah. And then there's a graph right there, a ball and it's with its initial weight, and it just goes down and down and down. It's always moving towards that lowest point, and the way it connects is because the models always updates until the prediction has least error. All right, and now we have probability and statistics. So AI really, like, it does not predict anything. It rarely does it with 100% certainty, but probability, obviously, it measures uncertainty, right? And statistics help us. It helps us to summarize and analyze data that we get, right? I would recommend you guys to review basic statistics, mean, median, standard deviation. I think in the next previous slides, I'm going to go over standard deviation. Yeah, let me check it out. Yep. All right. So standard deviation, you guys should write this down. So it measures how spread out the data is from the average or mean, right? And there's two different types. We have a small standard deviation, which means that it's very close to the average, the values, right? And then we have a large standard deviation, which means that the values are very spread apart over a wide range of different values. So take a second to write this down, standard deviation. I think we all know this because it's used in experiments, really, scientific experiments when measuring data. But it just checks how spread out it is from the average or mean. And then it checks, there's two different types, a small standard deviation and a large one. I'll give you like, maybe like 5, 10 seconds. Just get your notes and type this out. Pretty simple topic, though. We should all know this by then. Um, yeah. So I provided an example, right? Imagine we have two classes that took the same math test, right? We have class A, which has 79, 80, 81, and 80 and 80, right? When we do the average and add all these up, we'll get 80, right? So we look at this and we compare that average, which is called the mean, and we see it's very close, right? 79 is pretty close to 80. 80 is exactly 80, and 81 is also pretty close to 80. And all these values are very, very close. So that makes it a small standard deviation, as I was talking about earlier. Next up, we have example two, right? We have class B. The averages is 40, 60, 80, 95, and 125. We had a super genius, right? He got 125 in that one test. And again, if you want to calculate it, but the average is going to be 80, right? And if we compare the average, which is the mean, we see that the values are very spread apart. We have 40, 60, 80, 95, 125. That's pretty far apart. So it's called a larger standard deviation. So you may be asking, how does this even connect to machine learning? Again, machine learning, it learns by finding patterns in the data set, right? So if the data is very spread apart or contains unusual values, it makes it much harder for the model to find the correct patterns, right? So by measuring how spread apart the data is, we can decide whether or not we need to adjust the data before training. And this makes the model have much more accurate predictions. So this is very important, this idea of standard deviation. We got to see if it has a large or small standard deviation. It's always best to have a small standard deviation to get more accurate predictions in a model. Give you a few seconds to type this out. Um, let's see. All right. So we have a normal distribution, and many data sets, as we can tell, it has a bell curve. And in this image, the center represents the average, and the spread shows how the values are kind of differing, right? We have outstanding. These are just performances. This is a random example I got online. In machine learning, understanding how the data is spread out allows us to detect any unusual values, and it helps us predict the data much more accurately. And through that, models can be built, and the model would predict much more accurately again. What is going on with the computer? All right, yeah, that's normal distribution. Kind of a weird image to use. I don't know why I used that one. All right, why Python? So, I mean, Python is commonly used in, it's a popular ML language. For its reasons, it's because it's very easy to learn and easy to read. It's cross platform. It has thousands of libraries and it's used by the industry quite a few times. So, again, if you want a tutorial on how to install Python, I'm sure we all have Python, but again, Python, it looks like this, right? That's Python right there. You just search up python.org and then just add it to path and then verify. I was gonna talk to Aiden about this. This is Google Colab. This is an excellent resource. I recommend y'all to use this. I'll give you guys again a tutorial. Just open your computer. I don't know what device you're on, but remember how to do this. But Google Colab, in the next lecture, I'll go over how we're gonna use this to actually calculate data and write some code. Because so far I'm talking about all the vocab, and I want to get into the actual part of machine learning. So we just go on new notebook. We create a notebook, right? And you can really name it anything. We can just do machine learning. Wow. And then you can just type in any line of code. So you can type in print hello world, hello Baljeet, right? And then we just run it. And basically it's connected through the Google servers. So all the data is on that. And you see it's going to connect. You see RAM and disk. It takes all that. You see it printed that. So you can pretty much code anything, and you can also make this kind of a prediction tool. I don't have any coded stuff on me right now, but if I did, let me see. Yeah, but that's pretty much it for Google Colab. Just make one and try to like you see how it works and functions because it's very important. Um, you can also add more lines. Create more tabs. You can hide the output. But yeah, it's very, very nice. And you can even add text on here. You can bold it or maybe do this, italicize, totally up to you. But yeah, it's a cool feature, cool website we're gonna start using in the future lectures. But I gave y'all a simple tutorial. You guys can also use Kaggle.com, but I would recommend you guys to check out Google Colab. It's very good. Simple and intuitive to use. But you just make an account, register. I'll publish the slideshow. But let's move on. Yeah, I said where to code. We can use VS Code. We can use Jupyter Notebook or Google Colab. Right, it runs in the browser and it supports all GPUs. So I would say focus on Google Colab. It's very easy and simple, intuitive for all of us to use. And we have NumberPy, right? It basically performs the mathematical operations in a way that's very fast, and it does it on arrays. I've actually provided an example over there. So you import it as MP, and then you put all the data value, and then it will print out certain operations on the arrays. Pandas. So I'm not very familiar with this, but I had to do a bit more research on pandas. But again, it's a Python library. And what it does is it organizes data sets through data frames, right? It's very useful for reading stuff as in files, cleaning data, or just analyzing information. I can give y'all one scenario. Imagine you have a spreadsheet with thousands of students' grades, and opening that Excel is very, very easy, but analyzing it manually would take forever. Through Pandas, it lets Python read the spreadsheet and organize it into a table called a data frame. So it can then search, filter, and calculate the averages and basically removes all the dumb values or missing values. and prepares the data for machine learning. And it's kind of like Excel. That's kind of how I remember Pandas, right? And you can just do this through a few lines of codes. So it just cleans data and it's very good at analyzing information. In your free time, I check out a YouTube video on pandas. It's very interesting. It's a Python library. Remember that. And then we have Matplots library. So what it does is it creates graphs, as you can see on the bottom right handle corner, from the data that you give it, right? So we have common charts. You can have line graphs, bar graphs, scatter, histogram. So it's a graph maker. It turns all the data you give it into charts. You can also check that out on your free time. It's very, very cool. I think in the maybe the last presentation that I'll give, I'm not sure, maybe somewhere in August, I'll go over how to create a graph from the data you give. And then we have scikit-learn. So it's a machine learning library and it contains all of the stuff that a machine learning model needs. It's basically a toolkit. It has linear regression, it has decision trees, k-means, and it contains all the ML algorithms. So it's very important. It's like the kind of like a med kit, very important. Scikit-learn. We have PyTorch versus TensorFlow. PyTorch, in my opinion at least, it's very flexible and it's very popular in research actually. People use PyTorch a lot. I was talking to Aiden about PyTorch. Um, TensorFlow, it's very good for deployment and production systems. It's very important when it comes in deep learning toolkits, and with this, you're able to build neural networks. I believe in the beginning of the slideshow, I was talking about neural networks, and now we're going to get into that. So, what is a neural network? It's a machine learning model that learns patterns from data by making predictions and learning from its mistakes. And through that, it improves over time, right? So, as we know, it comes from the neurons in the human brain, right? Just like how neurons pass information to one another, a neural network consists of many small processing units that are called artificial neurons, and they work together to solve problems, right? This is used whenever your computer needs to recognize complex data or make intelligent decisions. For an example, you can think of a Face ID scan, right? They use artificial neurons to work together and process what's going on. Like the Face ID scan that we have on our maybe our laptops or on our phones. That is an example of a neural network. Yeah. And that's basically it. The review was we just went over why math is important, how does gradient descent do, what does gradient descent do, and why is Python popular? Well, these are questions, but I don't really want y'all to answer them. I'm gonna give you all the slideshows because we don't have much people today, unfortunately. Um, yeah, I would say for now to focus on standard deviation, probability, and statistics. Gradient descent is also pretty important. I don't expect y'all to know calculus. I don't even know that much calculus myself. Um, so don't worry about calculus. Just understand what it is. Matrices for sure understand that. A vector is linear algebra, basics of it. Um, understand what a bell curve is in distribution, Python, and how to install Python if you don't already have it. But the main resource that we're going to focus on is this right here. So just if you can right now, Luna, I'm not sure who else is with you. Just make a new Google Collab. If you can. I'll give you the URL link. I'll provide it. That's pretty much it for the lecture. Let's see. Stop streaming. Gonna check out something. 1 second. I'm gonna provide the slideshow. If you have questions, just type it in chat. Where is it at?